Alright, in this situation we are having the diagram ABC are the vertices of a triangle ABC, and M is the midpoint of AB as indicated in the diagram. Then N is a point on CA such that MN is parallel to BC, which means these lines are parallel to each other as shown in the diagram. So now we are to determine the coordinates of M, which is the midpoint of this line BA. So how do we do that? For midpoint, so midpoint is given by, we have x1 plus x2 divided by 2, then we have y1 plus y2 divided by 2. So we just need to figure out what are these values. So x1, let's give it as 2, and x2 is 6 plus 6, then divided by 2. Then y1 is 15, then y2 plus negative 2 divided by 2. So we are having this one. So 2 plus 6 is 8 divided by 2 is 4. Then therefore 15 minus 3, 13 over 2. So we have 13 over 2. These are the coordinates of M, which is the midpoint of this one, which is, this is 4 is 2, 13 over 2. And of course they both have to be positive because this is first quadrant. So we are done for that one. It is given as midpoint, then use midpoint theorem. Now we are to determine the gradient of Mn. The gradient of Mn, remember this line is said to be parallel to this one. So what do you know about parallel lines? They share the same gradient. So it's really not easy now to determine the coordinate, the gradient of Mn, if only the value, if only the point M that you know the coordinates of. So what about N? So we need to find another way of finding the gradient of this line. So once the lines are parallel, they share the same gradient. So which means the gradient of BC is equal to the gradient of MN, because the lines are parallel. Lines are parallel. So what are we having? Let's find the gradient of BC so that we incorporate and say this is also the gradient of Mn. So the gradient of BC is equal to, so y1, let's say 15, minus y2, which is 3, divided by x1, which is 2, then minus x2, which is minus 4. So this is what we have. So 15 minus this is 12, this and that, this is 6. So the answer is just 2. So the answer is 2. The gradient of this line is 2. So the gradient of this line is also equal to 2, because these two lines are parallel to each other. Then we are done. We figured out that the gradient of Mn is also equal to 2 because of that theorem. Now moving forward, hence or otherwise determine the equation of Mn, the equation of this line, in the form of this. Now we know that the gradient of Mn is solved as 2. Then we are having this scenario now. So having this one, equation of Mn is 2x plus c. We just need to figure out what is the value of c. Which point that is given them is 4 is to 13 over 2. So we really need to use this point because we actually don't have n yet. So in the place of y, we put 13 over 2. Then in the place of x, we put 4, then plus c. Then your c is now going to be equal to negative 3 over 2 if you press your calculator wisely, because 13 over 2 minus 8 is negative 3 over 2. So this is what we have for the equation. Equation is equal to 2x minus 3 over 2. Then we are done. Then moving forward to figure out some other information, we are to calculate with reason the coordinates of n. How do we determine the coordinates of n? Remember, we really don't have a single coordinate there. We just have n, not knowing anything about it. But the idea is this is in the midpoint and this line is parallel to each other. just need to remember about the midpoint theorem, that if one line bisect one side of a triangle and parallel to the other side, it has to bisect the third side as well. So which means this side is also being bisected. That means N is also the midpoint of CA in that way. So this is a midpoint. This is the converse of midpoint theorem. So we say N is a midpoint of AC. Reason this is a converse of midpoint theorem. So if this is the case, if M is the midpoint, then this line is parallel to that one, then therefore this one also going to be the midpoint of that one. So we really need to also remember such things. So now the idea is to figure out what are the coordinates of N. We just need to figure out the midpoint of what? Of CA or AC. So the midpoint of AC is what? It's going to be x1 is -4, then x2 is 6, then divided by 2, then y1 is 3, then y2 is -2, then divided by 2. So this one is just gonna be 1, then this one is just gonna be 1/2. So it makes sense. So we have N having these coordinates. 1 is to half, and of course both of them has to be positive because N is on the first quadrant. So let's move to the next question now, especially if you don't have a question. Now let's have this one. In this scenario, if A, B, C, D in that order, which is A, B, C, if we are moving this way, D can be somewhere here, and we really don't know, but it is somewhere here if we follow this order. So we have A, B, C, D is what? Is a parallelogram. Wow, it's a parallelogram. So we need to join out these points now to show that this is really a parallelogram. So let's say this is DM, so that we have a quadrilateral, which is a parallelogram like. So let's say we are having this one, but what we know about this, about parallelogram, when now we are solving, what we are determining the coordinates of D. Determine the coordinates of D. How do we do that? So the idea is to remember the properties of a parallelogram, that the diagonals of a parallelogram, they bisect each other. So on that note, this line passing through and going straight to D, and this passing through and of course going straight to A. You just need to remember that the diagonals of a parallelogram, they bisect each other. So which means this N is the midpoint of this diagonal BD. Okay, so and of course we already have the coordinates of what? Of N. It was given as 1 is 2, 1/2. So these are the coordinates of the midpoint. So if you have the midpoint and one point in the line, you can easily find the other point. So how do we use our midpoint theorem in this case? We have mx, which is the midpoint of x. The x coordinate of the midpoint is equal to x1 plus x2 divided by 2. Then we also have the y coordinate of the midpoint, that is given by y1 plus y2 divided by 2. I'm just breaking this midpoint theorem, this midpoint formula, so that we find what is missing. Then now what are we having? We have these coordinates and these coordinates. We have these missing coordinate. Let me just say this is x2 and the other one is y2. So we are looking for x2 and y2. So on that note, we have mx. This is the x coordinate of the midpoint. Let's put it, this is 1, remember. Then this is equal to x1 is 2, which is this one, then plus x2 we don't have, divided by 2. Then let's come to y. Y coordinate of the midpoint is half, remember. Then we have 1 over 2 is equal to y1 is that 15. So we have 15, then plus y2 is this one we don't know, then y2 is that one. So now let's solve the value of x2 and the value of y2. So crossing, we have 2 minus 2, which is x2 is just going to be giving us 0. Then crossing as well, we have 1 minus 15, that is going to give us y2 is equal to minus 14. So d is 0 is 2 minus 14. Wow. So which means really our point D is right on the y axis. So this is what we have. These are the coordinates of D after we have constructed this, because if you can't find the information about the diagram, which is abstract, just construct it so that you get the information about what is being required. Hence now we ended up having the quadrilateral out of nowhere. Now we are done for this one. Let's get into the next one, which is this one. Before that, let's go to a break.